This is video 4 for the ANCOVA assignment for Psych 642. As I mentioned where I left off in the previous video, this video will focus on actually creating and running the ANCOVA model for the SO depression dataset. Before running or building the ANCOVA model, there are two things that I have to look at. The first is, how am I going to deal with the issue of order in the model? And the second is, what type of contrast do I plan to use? So first things first, as far as the order, I plan to use type 3 sums of squares in order to deal with that. And because of that, it influences the contrast. I have to use an orthogonal contrast so that the type 3 sums of squares get calculated correctly. So specifically, I've chosen to use the Helmert contrast and to set that for this, just because of the hypotheses that I talked about in one of the previous videos. I specifically want to see if those in sexual minority groups have different depression scores from those not in sexual minority groups, as well as whether bisexual individuals differ in depression scores from homosexual individuals. So kind of breaking down the first subgroup of sexual minority and seeing if there are any differences between the two. That fits with the Helmert contrast. That's specifically what it is designed to do. It looks first at control versus the other two groups, and then it parses apart the other two groups and compares them. So that's specifically what I'm trying to do, which is why I chose to use this specific contrast. So I'm using the Helmert contrast function. I've specified the number of levels of my independent variables. There's 3 there. There's heterosexual, homosexual, and bisexual. And I specifically set those contrasts for the sexual orientation variable in the SO depression data set. So I'm going to go ahead and run that to set up those contrasts. And there's that. Now that that's been done, I can create the base model for this ANCOVA. That's done using the AOV function, just like for the ANOVA. The difference is I'll be adding in the covariate as another predictor variable that will look, and this will cause the model to look at sexual orientation after looking or controlling for family income. So you can see I've set up the ANOVA model with the outcome variable of depression, the covariate family income, and the independent variable or predictive variable of sexual orientation from the data set called SO depression. I'm calling this model SO Inc model, which basically stands for sexual orientation and income model. So since I chose beforehand to use type 3 sums of squares instead of type 1 sums of squares, or type 2, I also have to use another function to specify that I want to calculate the information for this model based on type 3 sums of squares. To do that, I use the ANOVA function and just put the name of the model that I created in here and specify that I want to use type 3. So I'm going to go ahead and run that. And as you can see down here, that gives the results of the ANOVA. And you can see from these results that both the covariate as well as the independent variable, were both significantly related to the outcome variable of depression scores. So there were differences, significant differences found based on both family income and sexual orientation. So when looking at this and when comparing, one of the things that I want to look at is the means. And we took a brief look, let me scroll back up here, at the means here and kind of made some quick judgments about what we might expect for depression scores between sexual orientation. Since we added a covariate into this, those means are no longer correct. The means need to be adjusted for the effect of the covariate. So in order to do that, we have to calculate the adjusted means. So I'm going to be using the effect function in order to accomplish this in R. As you can see that we put in SO as the grouping variable here. We put in the model that we're wanting to adjust for, which is the SO Inc. model that we created for our ANCOVA. And then we also set SE to equal true because I want the standard errors for whenever I'm reporting this later. So I'm going to run that. And that creates the object that specifies the information for those adjusted means. But I do need to run the summary function to actually get those adjusted means. It also gives the 95% confidence limits, both the lower and the upper. So this gives us our new adjusted means that we'll use when reporting on this model. As I mentioned before, in addition to the means, I also need the standard error. So I'm going to just run this line of script, which basically just asks R to show me the standard errors that were computed for the adjusted means object here. So I'm going to run that, and you can see the adjusted standard errors in the output here. So the last step to this for this specific study is to look at the planned contrasts that we set up based on our hypotheses. So the summary.lm function is the function that gets used to look at the contrast that we specified in the very first part of this video. So I'm going to go ahead and run that. And we can see that there was a significant difference between heterosexual and sexual minority depression scores. And then looking at this one, we can also see that there was also a significant difference between the depression scores of homosexual individuals and bisexual individuals. Now, if we had not specified contrasts or specified specific hypotheses about the group differences, the specific group differences, then instead of using plain contrast, we would use post hoc tests. For this specific study, I'm not using post hoc tests, but this is what it would look like if I hadn't gone into this with any with any hypotheses. So we would use the GLHT function to do the Tukey post hoc test. So I'm going to go ahead and create the object that specifies that. And then you do the summary and confidence intervals to get that information about the post hoc object that you just created. And you can see here that there was a significant difference between depression scores of homosexual and heterosexual individuals, bisexual and heterosexual individuals, as well as a significant difference between bisexual and homosexual individuals. Now, this information up to this point, as far as the post hoc tests, and planned contrasts, and just the general ANCOVA model results, have shown us that significant differences do exist. However, it doesn't really give us any information on whether or not that significant difference really means anything, or whether the difference is important at all. So effect size is one way that we can look at how important or how large of an impact this difference really has. Specifically, we're looking at how much of the variance can be explained by our specific model when looking at effect size. So there are two different ways that effect size can be calculated. The first is partial eta squared. The formula for that is the sum of squares of the covariate divided by the sum of squares of the covariate plus residual, and then the same thing for the independent variable, just to see the effect of both of these things. So I've input the information already from the output for the sum of squares for each of these, both the covariate and the independent variable. So we can kind of scroll back up here. So I'm looking for our first model, which is right here. The results from our overall ANCOVA model. And you can see that the sum of squares are listed here. So the sum of squares for family income, the covariate, is put in there and in there in the formula. And then the sum of squares of the residual goes in here. And then I'm going to go ahead and run that and show it to you. So we got a partial eta squared of 0.78, if you round up to 2 decimal places. And then I got this information from the same exact place in the output, just for the SO instead of the family income. So I'm going to go ahead and run that as well. You can see that the partial eta squared was a 0.87 for sexual orientation. So it does appear that sexual orientation had a slightly higher effect than family income on depression scores, but both of them seem to have a very high effect on the outcome of depression scores. So that is one way to calculate effect size. This is where we're going to stop for this video, and then for the next video we're going to pick up right where we left off with calculating effect size for the specific planned contrast interactions, and then test some more assumptions.